Welcome to another micro lesson for microbats. Based on the introduction posted a couple weeks ago, the next series of lessons are going to be discussing measurements, various aspects of those useful for identification, essentially related to call parameters and measurements. Part 1 will look at frequently reported but not useful parameters for species identification. To quote Krebs, as I did in the introductory one, the problem that all sciences face is what to measure, and the history of science is littered. You go to the literature and you'll see that, littered in the literature, with examples of measurements that turned out not to be useful. Bat call data in publications fall into this category. And again, Krebs's rule number 1, not everything that can be measured should be. Measuring these parameters wasn't restricted to software specifically for bat acoustics. In fact, a lot of them where you could readily measure these parameters were software that was developed for just general sound file analysis, such as Raven, Audacity, and others. A lot of people in Central and South America are using free versions of these because it gives them an opportunity to try and measure call parameters. However, it's really not doing you many favors because it's not providing you with the call data that you need for identification. So programs like Bat Sound, Kaleidoscope, and others can also be used to manually derive these values for bat calls, and these have often been reported in publications. Here are two of the measured and published values that are not useful for identification that I'll address today. Start frequency, end frequency. Been seeing this a lot, and today we'll go through why it's not very useful and why you shouldn't waste your time trying to report on it, measure it, let alone try to understand it beyond what we're going over today. A lot of the early publications that included start and end frequency parameters were extracted using time expanded data or calls. This is when calls are recorded on a tape recorder and then played back at a much slower speed to, quote, expand the time and then extract call pulses. Even earlier, with call sound data, they were displayed on oscilloscopes, where you would essentially get a wave file moving up and down on an oscilloscope, and people would take photographs of them with old film cameras and try and derive measurements from various parts as the calls varied in value as they streamed across the screen. So I didn't do a complete literature search by any means, but well over 20 years of publications that use start and end frequencies in their methods and what they're describing. The most recent was one from Argentina. I'm not picking on any given set of authors or isolating them for criticism. In most cases, the more recent authors are simply mimicking what they've seen published in the past and went, oh, if somebody else used start and end frequencies, I better too. Well, hopefully in the future, none of you will use start and end frequency, but we will talk about all of this and see how useful that set of parameters actually are. Now, looking at the methods section of most of these papers, most of them use three major software. Bat Sound, that's out of Lars Peterson's lab or office in Europe, Avisoft, Call Viewer, and then a couple used Raven, and maybe one may have used Audacity. But looking at their methods section, they all talked about the following parameters were derived. Start, which is f start, and end frequency, fn, measured in kilohertz. And then a lot of these papers discussed bandwidth, and they defined it as the difference between the f start and f end. This is where my head exploded and my knees jerked. This is usually defined and standardly expected to be based on the maximum and minimum frequency. It has nothing to do with where frequencies start and end. And at the end of this little micro lesson, you'll understand that, hopefully, very clearly. So, most of these papers also included some useful values, such as the maximum frequency of energy, FME, or peak frequency, although a separate micro lesson will discuss how useful those really are, as well as some slope measurements that vary quite drastically. But in any case, these papers reported one of these as at the maximum intensity based on a power spectrum, meaning the loudest part of the call, maximum energy. And then, of course, the min, max, duration of each call, and the interpulse interval. So the papers were useful that they were putting out at least some standard values in addition to this start and end frequency. Let's clarify things. That f start is not the same as f max, or maximum frequency. F end, or end frequency, is not the same as the minimum frequency. So let's look at some examples from different families, call shapes, and species, and see why f start and f end are not useful for identification or even characterizing a species' diagnostic vocal signature. Vespertilionids provide examples of where the origin of start and end frequency likely started and why it may have been considered useful. Some of the early acoustic research on bats was begun in Europe, and most of the species there are Vespertilionids that they were readily able to capture and record in labs. Aside from the fact that it was easy to measure, there were a lot of Vespertilionids to deal with. So I'll use an example of Neoptesicus furinalis that was considered Aptesicus furinalis, Argentine brown bat. It's now, the whole genus has been split, and most of them are Neoptesicus now. This is a widespread medium-sized Vespertilionid from Central America down into South America. For this group of species, the f start and f end are also actually close to the standard measurements of f max and f min. So you can see how this concept of these parameters may have begun. However, both measures face the same inherent issues of variability. It's important that all of you understand that high frequencies attenuate with distance, and this is important. The bat has not changed the calling frequency. So, in this case, this would be what the calling frequency of this Neoptesicus furinalis was actually emitting. What we recorded was this. The high frequencies recorded will increase as the bat nears the microphone, and as it flies away, the high frequencies attenuate rapidly with distance. The bat continues calling in this range, and what we're seeing here is only what we're recording related to the physics of sound, with high frequencies attenuating and not being picked up. from any distance. So, from the origin of the concept of start and end frequency, if we look at start and end and F max, they're fairly close. There are some differences, has to do with the vagaries perhaps of where on a sonogram or oscilloscope or whatever the person had their cursor, like I have up here. Where does that start frequency begin? Up here, here, but you can tell they increase and then decrease. The end frequency, on the other hand, is pretty close to the F min and remains more or less constant. Let's look at a smaller Vespertilianid, Myotis elegans. This is restricted to Mesoamerica and northern Central America, the little tiny guy. And those of you that are well versed with bat acoustics will probably immediately notice this is the same species, but they're at different frequencies. Yeah, of course they are. This is jamming avoidance. This guy was flying in here. The second individual came in, shifted his calls up a little bit so not to be interfering with returning echoes from this guy. And when this guy flew away, he started dropping down into the characteristic frequency. But we have the same issue, increase and decrease of the high frequencies. So F start, F max, not really very useful for the Vespertilianids. We have another issue with Dasypus iga. This used to be Lazuris iga, and then the genus was recognized and split into 3 separate groups, which is actually quite useful. But all the Lazurines are characterized by the FC, the characteristic frequency of the dominant harmonic, going up and down, changing. So this pattern here, up and down, is diagnostic for all the Lazurines. So, F start, variable like all Vespertilianids. F end, well, some are high, some are low, and some are in between. So that may not be that useful. Another issue with F end is frequently with Vespertilianids, we have calls that have what we call a toe on the end of it. So the end frequency is actually higher than the minimum frequency. So F end may not be that useful. So let's look at how well or not F start and F end apply to other groups of New World bats. Here's a real common molossid, Promops centralis. And I say common because acoustically you find it in many, many, many areas, even in urban areas, in towns and villages, and high above the canopy. Rarely netted, rarely captured, but acoustically pretty distinctive and readily recorded. These calls are single pulses, go from low to high. And there's a different pulse that they throw in from time to time. So if we zoom in, F start, F end. F start is actually close to the minimum frequency. F end is actually below the maximum frequency. So the minimum frequency is close to F start. If you were paying attention, hopefully you weren't sleeping, you noted that the Vespertilianid examples, F start was close to or equal to F max. The F end was close or equal to F min. Now, with the very first example of a molossid, F start was close to or equal to F min, F end was close or equal to F max. So think about this, 180 degrees or opposite difference. And we'll look at the odd little pulse that Promops do. And all of Promops, all the species have the same characteristic shaped calls, and they all include the upper decreasing frequency call. So the F start is actually a high frequency, F end is actually a low frequency on those pulses. Here's another mollossid. Very common group, the molossus group. This is nigricans, was called rufous, in the old literature ater. However, they've been separated out. Rufous does occur in South America. This recording is from northern Central America. And the whole genus is characterized by paired pulses. Bing, 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 decreasing frequency pulses. So we've got an F start and F end. Then on the lower pulse, F start, F end. So you would have two completely different sets of values, not very useful for identification of molossus. If you look at the body of the calls and look at call identification of something that's useful, which I'm just throwing in here, and we're looking at measurements, well, the characteristic frequency of the species and the characteristic slope, and the slopes are what tell you what the call shapes are. Negative numbers, the slopes are decreasing. Positive numbers, the slopes are increasing. And of course, Fmax and Fmin is also useful, and that is a parameter that is used. Nowhere do you see F start, F end in there because it's not useful. Here we go, another family, another genus and species, Noctilio leporhinus. Where to measure start and end frequencies? Well, in some cases you only pick up, depending on the distance from the bat, these type of calls. And we'll revisit these calls, or this shape of call, with an entirely different family, genus, and species in just a moment. Where do you start for F start and F end? Here, the longer tail. Let's look at another longer sequence. Here we've got long descending following frequency at FM, frequency modulated pulse. So F start, F end may not be that useful for Noctilio. Throw this in, and that's a whole separate topic, but since we're looking at similar call shapes, here's Rhynchonictris naso, an emballoneurid. Coincidentally, it also forages over water like Noctilio, but we're not going to go down that rabbit hole or go deep in the woods today on similar shaped calls. That's a whole different topic. Here's our friend that we just looked at, the upside down hoop shaped calls, which are characteristic of emballonurids. This is Centronictris centralis. Very distinctive, closely spaced, similar shaped pulses, all at the same frequency. F start, F end. Interesting. So F start and F end are almost identical, very close to F min. So, how useful is start and end frequency when they're both exactly the same or very close to it? Not telling you very much on what's useful for identifying that species. Oh my, yet another call shape. This is Pteronotus fulvus, used to be Pteronotus davii until it was recognized to actually be multiple species scattered throughout Central and South America. And these call shapes are very distinctive. The lazy S or lazy Z, reverse S. So, where would you measure start and end frequency? Something to ponder. They start down here, they go up, they come back down. In some cases, they come down and then go up again. And this is a species, another Morboloppid that everybody recognizes. Pteronotus mesoamericanus was widely known as Parnellii way back when, but that's now also in the group Phyloidea and probably represents 5 or 6 species. Constant frequency bat, almost all of the call is at the same frequency. So to be useful for identification purposes, I suggest everyone use standard and comparable measurements, not just those that were used in the past because somebody else published them means you need to. They made a mistake, don't replicate it. And these were easy to measure in the old days. I could take my cursor, measure the start of this N, measure the bottom, the end part of that N. So if we're measuring that font, I've got a beginning and end of the N stroke. What does it mean? A number on that will not tell us what an N looks like. Anyway, use those parameters that are useful for comparing similarities and differences. Call parameters need to be applicable to all taxes and not limited at best to a small subset, such as it was in the beginning with the Vespertilionids. Carefully vetting your calls takes time. Why bother manually measuring and extracted parameter values that are of no value to you? Your time is better spent looking at call files than looking at more and even more, so you become proficient with pattern recognition and are quickly able to identify your species. So remember a new rule, not rule 1, not everything that can be measured should be, but this is rule 1B for bats. F-start and F-end can be measured, but they should not be. So hopefully you'll be on your way to only measuring and reporting parameters that are useful. So until next time, when we look at another rogue parameter that's not very useful for identification,